Flack math! Give me some math and I'll give you some flack. Flack math!
We're going to talk about subsets. So we've already talked about sets. And did we have one on our test? Or this is in set A, is this true, false, those true, false questions, do we have those? Okay, so subsets are just sets within sets. All right, so for example, if B is the set 1 and 2, and A is the set 1, 2, and 3, then B is a subset of A. So that's the symbol for subset. It's kind of like a far-reaching C, okay? So it looks like a kind of a less than sign too, which makes me feel a little better because if it's a subset, it's going to be smaller, right? So this guy will always be smaller. Now there's no such thing as this, so don't do this. It's not reversible or anything. It's just one way like that. It looks kind of like a member of or an element of, but it's a subset. So yeah, every member of this is also a member of this. So it has a similar symbol, but it doesn't give you the details. Okay. So we could also say that A is not a subset of B, right? Because A doesn't fit inside of B. A is not smaller than B, but it doesn't, like all the elements of A are not in B. So 3 is not in there, so it's not a subset, okay? Thank you. Hey, Zan, before I forget, you said you wanted to use a free problem set, but I didn't.
No, I'm going to do.
Okay, it's not due till tonight, but yeah, you ran, but you could get one today. That's the hope. All right. Okay, so we're talking about subsets. B is 1 and 2, A is 1, 2, and 3. So B is a subset of A. So all of B is part of A. Okay, so far this is the new symbol. B is a subset of A. A is not a subset of B. Okay, so let's see. We could also say this, like if C was this set, 3, 2, 1, which is basically the same thing as A, right? Then we would say, and C is also a subset, but we would call it an improper subset. But it's still a subset. Okay? So it's kind of like, the improper fraction is like 6 over 5 and 7 over 5. But also an improper fraction is 5 over 5. Okay? So that's an improper fraction because you can just call that 1, right? 5 over 5. So C is an improper subset of A, but technically it's still considered a subset. Okay? And by the way, A is improper subset of C. Okay, so if it's the same set, it's an improper subset of itself, basically. So far, so good. Real easy concepts, but these are the ones that really mess with like a dyslexic person or a dysgraphic person like me, because when you do the true false questions and you have stuff like this, then you're like, okay, so is everything inside of that B? And so it gets a little weird, okay? So I'm just warning you, all right? If you're struggling with that, then this might throw you off a little bit. But, so C is an improper subset of A. Okay, here's another subset. So a set that has no members is called what? What do you think? A set with no members is called?
A variable?
So, no. It looks like this is called, this is what it looks like. It's literally a set with no members. Okay? There's nothing inside of it. It's empty. So we call it an empty set. Or we also call it the null set. Okay? So you're learning new terms, not really anything difficult, right? It's just something you got to remember. So an empty set, that's pretty easy to remember because it's empty. Okay? Now, believe it or not, we use this. This is an answer in a lot of problems we do. Okay? Give me the set of all numbers that are a square root of -9. Well, there's no square root of -9 because you can't take the square root of a negative number in the real world. Okay, so that would be the answer, the empty set. Okay, did you have your hand up? Oh, yeah, good, good. Well, you did have your hand up, but you were pointing. But... All right, so basically, with another symbol that we use for this, and you've seen this, I'm sure of it, is a 0 with a line through it. Okay, that's the way I do it because I don't like to do the braces because it wigs me out, and I like to do too many bumps or whatever. So I like the 0 with the line through it. But a lot of people use that for 0. It doesn't mean 0 in math. It means the empty set or the null set. Okay? Now here's the deal. The empty set technically is a subset of A. Okay? Or we could say this is a subset of A. Or really the empty set is the subset of any set that has anything in it. Okay? So far, so good? Okay, so you're going to get some true-false questions. They're going to give you a bunch of sets, and you're going to have to say true or false, okay? I'm not going to go through those examples because they're easy, all right? You guys can figure it out and do it in your homework, okay? So let's, the second part of this lesson, we're going to talk about the subsets of real numbers, okay? So real numbers are basically every number on the number line. So, you know, when you graph x is greater than 2, you do a solid line. You shade in that number line, right? Because you have to include not just like 3, 4, 5, and 6, but all the numbers in between 3, 4, 5, and 6, all the way to infinity, remember? So that's why you shade it with a solid line. Okay? But there are subsets of real numbers. So let's talk about them. First of all, let's say real numbers is the symbol for real numbers is like this alien looking R. I don't know why I call it alien looking, but this is real numbers. So instead of typing out or writing out real numbers, you can just write alien R. Okay? So here's the subsets. The subsets are a couple things here. The subsets go into 2 different sections. You've got irrational numbers, and then you've got rational numbers. So rational, what word do you see in rational? Ratio. Ratio is a fraction, right? So a rational number is any number that you can write as a fraction. Okay? So it's any number you can write as a fraction. You can't write pi as a fraction. Pi is an irrational number. So that's an example of pi of an irrational number. Anytime you try to take the square root of something that's not square rootable, that is an irrational number. There's not a lot of irrational numbers that we deal with, okay? So this guy cannot be written as a fraction. The decimal will go on forever and doesn't have any repeating value, right? We're going to do that contest again for Pi Day, where if you can name digits of pi, you get money, okay? But rational numbers are any numbers you can write as a fraction. Now, like 1/3 decimal goes on forever, right? 0.3 repeating. But there's a pattern to it. So that's not irrational. That's just a pattern that goes on forever. So I think of it like this. When you think about an irrational person, they may talk about stuff that doesn't make sense. They like say things over and over, but they don't repeat stuff. They just talk about stuff that doesn't make sense, right? Like 0.3 repeating goes on forever. They're not irrational. They're just crazy because they keep saying that they're insane or whatever. But yeah, this will irrational number. All right, so rational numbers, and then you got underneath rational numbers, you got integers. Okay, so these are all the whole numbers and their opposites. Okay, this keeps going. Right, so it goes on forever in both directions. They're all the whole numbers and their opposites. So the numbers in between are the rational numbers, right? And the irrational numbers, but like 2.5 is a rational number because you can write it as a fraction. All right, and then below integers, you've got your whole numbers. And that starts with 0, remember? And goes on. And then under whole numbers, you got your natural numbers. 1, 2, 3. We talked about this probably the beginning of the year. Okay, but these are subsets of real numbers. Okay, so for example, natural numbers are a subset of real numbers. These are all subsets of real numbers. Okay, and actually, natural numbers, these are subsets of whole numbers and are also, it's a subset of integers and a subset of rational numbers. So all these are, these sets are subsets of the sets above them, okay? So all the natural numbers fit inside this set. All the whole numbers fit inside this set. You can see them right there. All the integers are also rational numbers. You can write all these as a fraction, right? Just put them over 1, right? Rational numbers are all part of real numbers, okay? So a lot of people like to see this as a Venn diagram. So you've got like a little Venn diagram. You got real numbers, and then you've got like irrational numbers over here. So you got your ear rats, and you got your rats. Okay, and inside the rats, you got integers. Inside the integers, you got wholes. Inside the wholes, you got your natural numbers, right? So that's like a good example of a Venn diagram. And all these numbers are inside. So rational numbers like 2/3 or something here, or -5/8 or whatever. But then you got your -3, -5, and then you got your 5 and your 6. Oh no, the only number that's in the whole numbers that's not in natural numbers is that 0, right? That's the only one in there. So this circle of the Venn diagram is pretty small because there's only a 0 in there. Okay, so then in your homework, you're going to get more true-false questions where they're going to say, okay, well, is this true or false? So I'm going to write these down just so you can see what I'm talking about. And not just true or false questions, but I want you to tell me what sets this is a part of, okay? So, example 2, here we go. 1/2 is an element of which subsets of real numbers? So where is 1/2? Which subsets of real numbers is it in, Nathan?
Rational?
Yeah, it's rational. So you can say rats. You could say real numbers if you wanted to, but really we're talking, if it's asking for subsets of real numbers, you don't have to say real numbers. But even though real numbers remember, are an improper subset, right? So you don't have to list it. I'm not going to count it wrong if you list it. I'm not going to count it wrong if you don't. Okay? All right. Let's do another one. Example 3. 5 is a part of which subsets? Yeah, which ones?
Integers, whole, and natural.
Yep, integers, whole, and natural. It's also a part of rational because you can technically write that as a fraction. So if it's a part of any of these, it's a part of everything above it. Okay, so your goal is to find the lowest subset that it's a part of, and then you list everything above it. Because 5's in there, right? Because if it's inside this circle, it's inside the bigger circle. So you can write it as a fraction, just put it over 1. So you would say natural, whole, integers, and rats. Okay? So 4 subsets. That's a big one. So natural numbers, that's a part of, all the numbers that are natural numbers are part of 4 subsets of real numbers. Okay, what about this? What subsets is this a part of? This basically says 3 times the square root of 2. Well, what's the square root of 2?
1.1.
Yeah, it's, what kind of number is that?
Irrational.
Irrational, okay? So if it's the square root of something that you can't take the square root of, that's irrational. If you do that on your calculator stops because it runs out of room on the screen. But if you did that on a real calculator, then it would go on forever, okay? And there would be no repeating pattern. It's irrational. It's nonsense. Okay, so this is just a part of irrats. Okay? So the only things you have to look for irrational numbers are radicals, square root signs, and like pi. All right? Unless, what if it's the square root of 9? Is that irrational? No, because what's the square root of 9? 3. Okay, so if 3 is actually a part of 4, right? Natural, whole, and everything. So first, see if you can simplify this. And if you can't, then you're done. This is an irrational number. Okay? Any questions with that? So basically, this 3 is just there to throw you off. If you can't take the square root of 2, if this is irrational, then multiplying it by a nice number does not make it rational. It's still irrational. Okay? All right. And then on your test or on your homework, you're going to get these true/false questions. So let me just write these out, and then you tell me if they're true or false. What does that alien R mean again?
Irrational.
Alien R means a real number, okay? So they do have a symbol for rational numbers. It's just capital R. So that's what they do to distinguish between rational and real. Capital R without an extra line is rational, but capital R with an extra line is real, okay? So what do you think? A, is that true or false? I heard a true, and then I heard a. So, raise your hand if you think it's true. Raise your hand if you think it's false. Okay, It's like 1 versus 2. Some of you are not participating. Okay, so you could think of it like this. When you're dealing with subsets, these are subsets symbols, right? So everything in this group can fit inside of everything in this group. So first thing you should look at is which set's bigger, or which square or which circle is bigger, real or integers? What does this mean?
I think it's true.
This statement is false. Okay, so this is what's going to mess with your heads. So real numbers, is not a subset of anything except real numbers. Okay, real numbers is the big one. Every single number. Now that is not a subset of an integer. An integer is a subset of real numbers. So if I reverse it, it would be true. This is false. Does that make sense? Okay, let's try it again. Irrational numbers. Is that a subset of rational numbers? No, there's actually nothing in common. It's not even like this is too big for that, or there's numbers in here that aren't in there. Well, there's no numbers in here that are in there, and there's no numbers in here that are in there. Okay? They're completely separate. Okay? So this one is like a separate circle inside the real numbers. Okay? All right. What about C? Whole numbers is a subset of natural numbers. True or false? Elkin says no.
I think it's false. What does that say to you?
No, you're right. Yeah, it said no, it's not true. I understood this. Yeah. You did that, but your answer was false.
This means true. This means false.
This means false?
No.
That's what you did. Okay, this is false. Elkin was right in his cryptid language. So whole numbers, yeah. So remember that 0 is a part of whole numbers, but it's not a part of natural numbers, okay? So does this subset thing make sense? It was a lot easier when we were talking about real, like numbers that we could see, right? On the last board. But on this one, it's just weird because you have to remember what numbers are in whole numbers, what numbers are in natural numbers. What about the last one? True or false? Integers, real numbers. True or false? Elkin says true. That's true. Yep. Integers are a part of real numbers. All these are a part of real numbers, even irrational numbers. Okay. All right. So take your time with this one. Make sure you understand this. This will be on our next test. So be careful. We'll go over it again when we review for our test, but slow it down. Make sure you understand. I think the easiest way to explain it is think of this as like a less than sign, okay? Real numbers, is that set smaller than the set of integers? No. I mean, technically, this has an infinite number of members, right? It goes on forever. So does this, but this kind of has a different level of infinity because all of these numbers are inside of that one plus some more, but they're still infinity. So it kind of messes with your head a little bit. But believe it or not, there are different levels of infinity. So the highest level of infinity is called infinity LF naught. So when I was dating my wife, which you met last week, wasn't that special? My girlfriend. I said, I love you to infinity LF naught. So I was a math major, so it's kind of a nerdy, romantic thing to say, but just forget it. All right. She knows what I'm talking about. She thought it was sweet, but she knew I was a nerd. I mean, I wasn't like a nerd.
Wait, what did you major in?
Math.
College? Just math?
Yeah.
In general?
Because I love it. All right?
Chill. Wait, what? I didn't know that
So
was a
the-
major.
actually,
Just
our
math?
first date, I had to break the date because we had this dress up math nerd party that I had to go to. It was actually called a dress up math nerd party. You dressed up like your favorite math nerd, which I don't know if there's like favorite math nerds out there, but anyway, I had to. I said I can't go out with you because I have to go to this math nerd party. But anyway, that was. She understood my priorities back then.
Wait,
They've changed a
so
little bit.
There's like you prioritize math over like marriage, like anything
At that
else?
time, you know, math was really important.
I mean, now.
Now it's
Okay,
just
that's
part of
true.
my life. I mean, math is a part of all of our lives. Okay, we're going to talk about square roots in lesson 62. Oh, by the way, let's just write our homework here. So we're just doing 61, 62, and 64. Okay, so what's the square root of 16? Quick!
4, 2, 4, 4. It is 4.
4?
Yeah.
Okay, all of you are half right. What else is the square root of 16?
2.
What else times itself equals positive 16? I gave you a big hint there.
2 to the third. Or no, 2 to the fourth.
Square root.
Yeah.
Using square root.
I know.
What else times itself equals positive 16?
Negative.
Oh, negative 4 times
That's
negative
right. So negative 4 times negative 4 also equals 16. So you've got two, and whenever you take the square root of something, you have two answers. Unless you're taking the square root of 0, it's only 0 times itself, right? But even 1, square root of 1 is not just 1, it's 1 and negative 1, because negative 1 times itself is 1. Okay? But if this is given to you, but you can assume just positive 4, okay? Unless it says give all the roots, or like solve for x. When it says like x squared equals 16, you have to solve for x. The two x's that would work would be 4 and negative 4.
Wait, so
But-
how would we answer that then? Like,
So
what
if
would
you
we-
just say, if I put this in your homework, and you just say 4, then you get it right. But you always have to consider that. But in this curriculum, especially when I just say that, you can assume I'm just talking about the 4. So I'm not going to trick you. I'm not going to trick you. Oh, you forgot the negative root. I'm not going to do that. Okay. So just be aware that technically there are 2, and we're going to talk about the negative root later. If I wanted the negative root, if I wanted to say this, well, this is negative 4. Because this is 4, right? And that makes it negative 4. Okay, so it's not going to be, well, that could be 4 or negative 4. So this could be negative 4 or 4. I'm not going to do that. So the negative square root of 16 is just negative 4. Square root of 16 is just 4. Okay?
Wait, what if you did the square of negative 16?
Ooh,
Like,
good.
what if you put
That's a good
negative
question.
on the inside of the?
Well, can you remember you can't take the square root of a negative number because nothing,
Oh,
because 4 times negative 4 equals 16. It's not something times itself because there's no number times itself that will ever equal a negative number. Not in the real world, but there is an imaginary world in math. And some of you know about imaginary numbers. That's an Algebra 2 concept. We're going to talk about imaginary numbers. Yes, it's a real thing. Imagination. Okay? All right. So, here's the deal. We've got... Okay. So, in here, this symbol is called the radical. This guy in here is called the radicand, not radicant, the radicand, okay? And this answer, the answer to a square root problem is called the root. So just like the answer to a multiplication problem is called the product, the answer to an addition problem is called the sum, the answer to a root problem or a is called a root. Okay, square root of something is that. Square root is 4. So the answer is 4. Okay, so these three symbols. Now, when we start doing like cubed root, that number in there, that's called the index. But if you don't see a number, that's the second root. The square root is another word for the second root. So what number multiplied 2 times equals 16? So the index, even though you can't see it in this problem, is 2. Okay? So what happens when you do this? So what's the opposite? Opposite operation of square rooting something. What's the opposite operation of square rooting? How do you go backwards? Exponent. So you go here, and then how do you get back to 16? You square it. You square it. The squaring or whatever, exponent. Okay, so for example, what's the square root of 2? Let's do 3 squared. So see how we're squaring a square root. What happens? Well, you could multiply. What's the square root of 3 times the square root of 3? Square root of 9, which is 3. So these guys cancel, and you're left with whatever's underneath that radical. Okay? You can do it the long way. What's the square root of 5 times the square root of 5? Well, you can multiply 2 radicals, right? What's the square root of 5 times the square root of 5? Square root of what?
Just be 5.
Well, the final answer is 5. But I'm showing you why it works. Square root of 5 times the square root of 5 is technically the square root of 25, which is, square root of 25 is 5. So don't do any more work than you need to. What's the square root of elephant squared? Elephant, that's right, okay? Do not attempt to take the square root of an elephant. That is messy business, okay? Don't do that. All right, so let's see. Irrational number is a number that can't be expressed as a rational fraction, right? Or it has a non-repeating, never-ending decimal. So anytime you try to take the square root of something that's not square rootable, it's an irrational number. Okay, we already talked about that. But there are perfect squares. Perfect squares are square rootable, which is not a word, but I've made it a word. So like 1, 4, 9, 16, 25, 36. How am I getting these numbers? You can take the square root of those. Square root of 1 equals 1. Square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. These are all square rootable. Okay? So these are numbers that you can take the square root of, and it's a rational number, right? I'm listing these up here. We're going to use these a lot, but this list keeps going, right? You can take the square root of all of these. Can you guys nod that you understand that? Okay, awesome. All right, so what are perfect squares? Well, we just talked about that. These are called perfect squares. This is not one word. They're just too snug together. Okay. Okay. So if you can't take the square root of something like the square root of 10, then the best way to say the square root of 10, the most exact way to say the square root of 10 is the square root of 10. Okay? It's kind of like the best way to say pi is not 3.14. That's just an estimation of pi, right? So the most exact way to say pi is just pi. So the square root of 10 is the square root of 10. If you give me an answer like that on a test, that's the exact answer that you can give me. If you don't give it to me like that, then it's not right. Unless I say round to the nearest hundredth-ish, then you have not answered the question correctly. So what is this, about 2 point something or 3 point something? What do you think? What number times itself would equal 10-ish? If you did it on a calculator, what do you think your calculator would say? Nathan?
3.3.
Yeah, well, maybe not 3, but 3 point something. So it's in between 3 and 4. This is a fancy way to say in between 3 and 4, because 3 is less than that, but 4 is greater than that. Okay? We did a little bit of that in pre-algebra, maybe at the end of the year. So where do you think the square root of 500 is? Let's not do that. Let's do square root of 50. Where's the square root of 50? In between which two numbers? Raise your hand if you know. So Nathan knows, but let's see if anybody else knows. So if you did square root of 50 on a calculator, where do you think it would end up? Between 7 and 8. That's right, because the square root of 49 is 7. So it would be 7 point something, right? So square root of 50 is in between 7 and 8. This is the fancy way to say in between 7 and 8. Okay? So you can't take the square root of 50, but you can tell me, like, where you think it would lie in between what two integers. So that was a question. I know it was a question in pre-algebra towards the end of the year, but now we're asking it now. Okay? So that's as much as you can do there. All right, so these are square roots. Let's talk briefly about other roots, like cubic roots and fourth roots. So there's not a special name for like roots after 3. It starts and ends with 2 and 3, so there's no special name like quartic root or anything like that. It's just called the fourth root. But let's talk about cubic roots. So you know this. What's the cubic root of 8? 2, right? Because 2 times 2 times 2, 3 2's multiplied is 8. So could you say negative 2 as well?
No.
No, because negative 2 times negative 2 times negative 2 goes back to a negative 8, right? So there's only one answer all the time for a cubic root, okay? Now you could say you can take the cubic root of a negative number, right? That's negative 2, because negative 2 times negative 2 goes to positive 4. And then you multiply one more negative 2. You're multiplying 3 negatives, which means you're going to end up with a negative. Remember doing that? If you're multiplying an odd number of negatives and you end up with a positive or negative. If you multiply an even number of negatives, you end up with a positive. Okay? So there's no double root thing with odd roots. Now, when I did like a fourth root of 16 is 2, right? But it's also negative 2. Because negative 2 times negative 2 times negative 2 times negative 2 also equals positive 16. Okay, so whenever it's an even root, there's 2 answers. Whenever it's an odd root, there's only 1. Okay? All right, so let's see here. And obviously there's an opposite. The cubed root cubed, what's the answer going to be? X. These cancel out, right? These are opposite operations. Cubing a cubed root are opposite operations. You can test it with a number if you want. So try 8. So the cubed root of 8 is 2, and then when you cube 2, 8, and then you look back at what you did and you regret wasting your life a little bit, okay? So when you have opposite operations, you don't have to do the math. Opposite operations cancel each other out, okay? All right, not that doing math is a waste of your life. It's very valuable. So let's get down to what your homework would look like in these situations. Yeah, I don't think we need to do those. Those are easy. Those are good. But look at this. So when I want to solve equations, you're trying to get x by itself, right? Now, you guys all know the answer to this, right? What does x equal?
That's 2.
2 or -2 if you're finding all the x's. But you could apply algebra. What's the opposite operation of squaring something? What? Square root, right? So we're going to square root whatever you do to one side, you have to do to the other. You see that? We did the same thing to both sides. That's what's cool about this. In algebra, you can do whatever you want to one side. You can paint it green if you wanted to, as long as you painted the other side green, because technically they would still be equal. It had to be an equal amount of green paint and an equal amount of green paint. Technically, it would still be equal, okay? So then you get these cancel and you're left with x equals 2, but actually, when you're solving an equation, you need both solutions, okay? Now, here's a cool way to write this, because this is a new symbol. This is positive or -2. Have you seen this symbol before? So you can use it so you don't have to write 2 answers. This is mathematicians' way of being lazy again. So you have positive or -2. This is also plus or -2. So if you had something like this, 6 plus or -2, there's 2 answers to this. What's 6 plus 2? Shout it out. 8. And what's 6 minus 2? 4. So the answers to this would be 6 plus 2 or 6 minus 2, which is 8 or 4. So there's 2 answers to that math problem. So that symbol gives you 2 options. Plus or minus, or positive or negative if it's just a number by itself. Okay. All right, so let's try something here. So this is, we're going to talk about quadratic equations a little bit more, but this is considered a quadratic equation. It's an equation because of the equal sign. It's quadratic because of that 2. Now, quad doesn't sound like 2. What does quad sound like? 4, okay? But dimensionally, if you think about like a square is also called a quad. Like if you know, like sometimes in a school, they have like the main square they call a quad or whatever. Okay, so that's a quadratic equation, but what's important here is that there's going to be 2 solutions. So sometimes this guy, the highest exponent or the degree of the equation, will give you a clue of how many solutions there might be. So if the highest exponent is 2, there's going to be 2 solutions sometimes. Sometimes there's only 1. If this was x squared equals 0, then there's only 1 solution. X is 0. Okay? But most of the time, that will tell you how many solutions you have. Okay? So let's see if we can do this. Order of operations, okay? So there's going to be a question like this on one of your tests. So see if you can do this. So how many answers are you going to have to this problem? Obviously, it's a trick question, but I set it up. There's obviously not going to be one answer. How many answers? Why is there two answers? Yeah, because you're going to add whatever that is, and you're going to subtract whatever that is. So it's going to, at the end, you're going to go in two different directions. So you have to include both answers. So give me the answers to that problem. That was a scary movie across the hall. You hear that? Do you have an answer? Okay, hold on to it. All right, where are you at? You have 3 points in Flack Attack coupons?
Yeah.
So let me give a Flack Attack coupon to get that, and then we'll do another one. So if you get both right, then you'll get up to a 5 points, and you can use a free problem set. All right, Micah, if you're still with us, text your answers to this. And if you get it right, you'll get a Flack Attack coupon. So you're going to need to write them down, though. Don't be fooled by this business here. Remember the rules on that? Don't be fooled. You have an answer too? Okay, hold on 1 second. Oh, I wrote the problem down wrong, but this will work. No. Yeah. How'd you get negative 31?
Isn't it like wait, what? Because I added first. I added those two first.
Oh yeah, you definitely don't want to add first before exponents.
Well,
Hold on to that.
no,
Okay.
I solved the exponents and then added those two.
Okay.
Actually, right, shoot, where you go? I actually got a 9 original. But I'm not going to.
Okay. Okay. What's that? Is that a 2? Yeah. Okay. That's one of them's right. Wait, did I do it wrong? Hold on.
I think you got my answer.
Yeah, I did it wrong. Oh, you guys are right. So one of those is wrong. One of those is wrong.
Well, I overheard you, so I know what the answer is.
Yeah, I heard what he said.
Yeah, good job. All right, anyone else? You fix it?
I fixed it.
You did?
I did.
Okay,
I won't fix it, but-
nothing? Okay. So let's see if Micah did anything. I don't see it. I think I lost him. Okay, so let's see here. Back row bandits. Got it right.
I like that. I see what I did.
Did you change yours, Nathan?
Well, I just saw what I did wrong, but I overheard you, so.
What's your answer?
8 and 2.
Okay.
3, 5.
Yeah.
I got it wrong because I thought that it was -3 cubed.
No, you got it right, didn't you? Change it?
Well,
and
the
you got it
first
right?
time I got it
Oh.
wrong, but then I
Remember,
changed
you
it.
wrote it wrong because I did -5 plus +3. I got -5 instead.
All right, Zan, you got one more. Let's see if you can pull it off here.
Wait, did I get it?
Yeah, you got a coupon. Yep.
I like the word flack attack better.
All right. Okay, I'll say Flack attack.
Attack sounds so much cooler.
Can you do that problem really fast?
Yeah, so this negative, see how the 2 is only squaring the 2 here. So this negative comes last. Unless there's parentheses around it, and then you don't. So this is negative 2 squared is 4. Okay? I'm not going to circle that.
I did +4.
Okay. So see how that's -4? Because this is not -2 squared. This is just 2 squared. And then you apply the negative later. Order of operations. First order of operations is parentheses though. So we apply the negative first and then we squared it. Okay? So this is +9. And then this is ±3, right? So we got, what is that? 5 ±3. So you go up 3 and down 3. Up 3, you get 8. Down 3, you get 2. Okay? Yes.
I just did my addition and my subtraction wrong.
Yeah, I think I did too. When I saw it, and I was like, oh yeah, that looks right.
I did. I got +4, -9. First time.
Yeah, so it's either one. Yeah, you kind of, it's hard to remember that rule. Okay, so let's try another one. Let's see here. Let's try one of these. Ready? Let's do this. This is, let's see if we can get all these right.
Wait. Oh, you're doing true or false.
Not true or false. If you get all these right, you get another coupon.
That's not that hard.
I know. You're welcome.
It's
All right, so all of you guys should get this. Yep.
still I don't see it.
Yep. Yep.
I just wrote them down.
Okay.
Wait, did you not get it?
So it looks like you.
So B more. Oh,
These are the answers. So I think you went the
first one's
wrong.
2, right? 2.
But I'm not sure what he did.
Oh, it's to the 4th. It's not.
Get it?
I got the first one. It was last one easy, but the second one.
Take your time.
Oh,
Yeah.
I just did to the third for the second one. So I thought it was 4.
I got 2. No, I thought it was 4.
I thought you did
I
last one.
didn't know it was. I was still thinking. I thought it was to the third. I didn't read it right.
So you can still do it on your calculator. but
Wait, I got this too, so that way. Oh, so I have 3 problems then.
What number multiplied 3 times is 8? What number multiplied 4 times is negative?
Huh? What?
Just go because negative 3 is positive. And negative 2 is
Ethan, you got up to a 5 too, so well done.
School ends on the 19th. The 23rd. We had homework to do. That was total bullcrap in my opinion.
What'd you get, Audrey?
Hang on. I saw the second one.
What?
The second one.
Okay, and so what's the third one? The pressure on. Yep, -3. Okay, so the question you have to ask yourself is what number multiplied by itself 3 times is 8? So 2 times 2 times 2 is 8. 2 times 2 is 4 times another 2 is 8. And what about this? So that's 3, because 3 times 3 is 9, times another 3 times 3, another 9 is 81. Okay, and then -27, well, the cubed root of 27 is 3, because 3 times 3 is 9 times 3 is 27. So -27 is just a -3. Okay, good job. All right, that's all I got for today.
Black math, give me some math and I'll give you some flack. Black math.